Okay, we can start. Thank you very much for coming. So my name is Achmad Mardiansyah, and then today I'll be talking about a topic here, up and running DNS service. So you as a internet community, either you're providing service or you're using service, you like it or not, you already use DNS service. Okay. So today we'll be talking about that. Some agenda. Okay, so these are the topics that we'll be talking about. Oh, okay, I have my pen here. I'm looking for a pen. Is there any pen here so that I can write something? Okay, here it is. Okay, this is my pen. Okay, so this is our agenda, introduction, and then review prerequisite knowledge, DNS system, configuration, live practice, and then Q&A. Okay, so first of all, for those who are new, we are GLC Networks. We're based in Indonesia. Our areas are training and IT consulting. We do MikroTik, Ubiquiti, Linux, and then we do regular events like what we are doing today. My name is Achmad. I'm based in Bandung as well. I'm a Linux user, other networking users, Linux user, BSD user, Unix user like a Solaris, a Mac user, whatever user, Ubiquiti. Also, we also do programming and then doing database. I'm teaching for living, okay, and then yeah, I have a LinkedIn account so that we can connect through LinkedIn. Our past experience mostly related to network. So I was working since 2004. Yeah, started from Linux administrator. I do set up DNS server, email server, web server, database server, many servers, and then I work in the telecommunication. And then going here and there, developing here and there with the programming and the networking stuff. And then here I am. Okay. So about the webinar itself, mostly the topics are related to networking, system administration, and programming. Yeah. Three topics, mostly three topics. Yeah, so and that's enough for me. And now it's your turn to introduce yourself. Okay, please introduce yourself. At least we know where you're from. Okay, usually there are people from from Africa, from Asia, South of Asia, like India or Nepal. Okay, or from Indonesia. Okay, of course, yeah. Right, thank you. First here, Rian from West Kalimantan. Okay, thank you very much. Okay, other people here, I can see there are 11. Okay, please introduce yourself. Don't be shy. Just tell us where you're from. Okay. So the prerequisite here is at least you know how the browsing works. You type a URL, an address, and after that, you know what happened. Okay, and then okay, after you know how the browsing works, at least it means that we already know that the computer networks already, you already know how a computer network works. Okay, right. Okay, I have a chat here from Ananta. Okay, thank you, Ananta. Welcome. Don't really have a networking experience. Okay, that's fine. Yeah, at least you know how networking looks like. Okay, at least you have an experience with that. Okay, so it's just a little bit about history. So about the internet, history of the internet. So initially it's a research project, and then become liberalization, so everyone can use it. And then now it's public. Okay, so everyone, you can use it massively. Okay, so before the internet, Computer networking already exists, but many are proprietary. Okay, so IBM can talk to IBM, DEC with DEC, Apple with Apple. That's not good. Okay, so we need to have a way so that we can talk to each other. Okay, regardless our brand or operating system or whatever. Okay, so that's why we need to define a standard for communication. Okay, with this standard, okay, regardless your operating system, your hardware, whatever, we are still able to communicate to each other through a setup of standards. So on top of all of them, the hardware, the operating system, we usually use a protocol named TCP/IP. So this is the protocol that unite us. So regardless your brand, if you are from China, you're from Europe, you're from Asia, you're from America, it doesn't matter as long as we are using TCP/IP protocol. Okay. Yeah, so after the internet, after we set up a protocol, the protocol that unite us, everyone can talk to each other. Okay, Apple can talk to Windows, can talk to HP, can talk to anybody as long as we are using the same protocol. Okay, so why we use the internet? Why? Because it's open. Yeah, it's a free standard. So previously, previously it was a proprietary, so Apple can talk to Apple. So that communication is very proprietary standards. Okay, so only them knows how to talk because they are define the standards. Okay, like the first 4 bytes means this one. The second 4 bytes is this one. Okay, and then yeah, that kind of protocol. Yeah, so yeah, with the use of internet, yeah, we can use it. Okay, we can use the protocol. Actually, internet is just a protocol, right? A bunch of protocol. In this case, is the TCP/IP. Right, so we have a lightweight, a global, so it's end-to-end, and then it's neutral by default. So TCP/IP is designed not based on the particular hardware. Okay, so that's why everyone loves it. When we talk about telecommunication, we also have layers. So each layer responsible for particular functions. Okay, we have in telecommunication, we have devices, we have a local loop, we have exchange, we have wires, and same thing with the traditional communications. Okay, so we have an application over here. Okay, but at the network side, we have its own protocol for communication. Yeah, and then the infrastructure also. They have their own infrastructure. So we have a cable for voice, a cable for video, right? Like a TV cable, coaxial cable just for TV. And then we have a data cables like Ethernet or wireless. Okay, and then this is not good. Yeah, it's wasting money because yeah, you need to have a separate infrastructure for each application. So that's why with the internet, we can combine all of them. See, yeah, so regardless your infrastructure, whatever, yeah, you can use wired, wireless, doesn't matter. And then in the middle, you have an internet, which is the TCP IP, right? That's the standard that unite us. And after that, you can access the application. And one of the application is the DNS. Okay. So when the internet happens, when the internet exists, so this is how it looks like. Okay. So actually, internet is it's a collection of network. Okay. So every organization, they must have a network over here. Okay. Yeah, network. Each network has its own IP address, a block of IP address. So you can see internet is a collection of IP addresses. Okay, and then you are part of it. Okay, so it's not like you connect to the internet. No, you are part of the internet, right? Yeah. So this is how it looks like. So you connect to the internet through your ISP. So this is you. only small dot of in the internet, and then you access other server, yeah, with IP address. So you will be using an IP address from that is given by your ISP. So your ISP has an IP address, a bunch of IP address, and then with this IP address, they will allocate one IP address for you, okay, so that you can connect to each other. Otherwise, you cannot connect because internet is based on IP address, okay, and then that IP address must be unique, right? Because it doesn't make sense if you have multiple IP address in some networks, and then how can you connect, right? How can the package is delivered to the destination, right? So it doesn't make sense. So the IP address needs to be managed so that there is no duplication of its usage. So this is how you connect to the internet. Usually we're talking about the physical topology. So this is you, and then you connect to the access network, and then connect to the access router, the router that connects that is located closest to the customer. And then from here to the cloud of network, a cloud of routers. Okay, there are lots of routers, and then they go to border routers and then connect to the other ISP. So if you see from top, like a bird's eye view, so this is how it looks like. So this is you, connect to the hub, and then connect to the backbone router, for example, and then connect to the border router, and then connect to other things. Okay, as simple as that. I think it's not that hard to understand, hopefully. So again, we need standards, yeah. So we need a standard for communication, okay. Yeah, so standard means an agreement. So it's like between communities, and then so it's formalized in the documents like ITF, W3C, and so on and so forth. So, and then we want that standard to be open, okay. Why it's open? Because everyone can use it, okay, freely accessible. If we know how it works, okay, the standards also define how the technology works. So with our understanding of how how it works, and then we can develop our own implementation of the standards, okay? Because standard is just a bunch of text, okay? And based on those texts, we need to implement that kind of text, that kind of algorithm inside the text into our programming language, okay? Into our Linux kernel or BSD kernel or whatever kernel, okay? So regarding the IP address itself, we need, as I said, internet is based on IP address, okay? And then this IP address protocol is defined in RFC 9791, okay? And then there is an international body, okay, that regulates IP addressing. It's called IANA, okay? So this is one big international body for all, yeah, for all of them. Yeah, for everybody. Oops, I lost something. Okay, no. Yeah, one big yeah, one organization for everybody in the world that is using internet. Okay, so that's IANA. Because it's big, IANA delegates the authority to RIR, okay, this one, and then RIR delegates to the country, okay. So every organization must have an IP address block here, okay, so that they can join to the internet. So the RIR here, we have 1, 2, 3, 4, 5 in the world. So for Asia Pacific here, it's managed by Apenic. Apenic is based in Brisbane, Australia. If you are in Europe or Middle East, okay, it's called RIPE NCC. Okay, if you are from Africa, and it's called Afrinic. If you are Latin America, it's called LACNIC, and then North America, it's called ARIN. Okay, so and then Apenic will delegates some of its authority to the regional registry or country registry. Okay, so that's how it works. Okay, but we're talking about DNS. Yes, I understand. So this is the DNS. Before the DNS, if you are using Linux, we are using that is a file that is called etc host. Yeah. So and then it has to be. So before, look, why do we need DNS? Because IP address is based on the numbers. Okay, so 10 dot blah 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 dot blah 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 blah, and then it's not brain friendly. Okay, yeah, not brain friendly. It is very hard to remember numbers instead of names, right? So what we do is we do mapping. So we say this IP address means this name. Okay, so we just, for example, if you ping, you just ping the name. You don't have to ping the IP address. Okay, so you just ping the name will be translated into IP address. As simple as that. Okay. Also, you have host.txt. Perhaps it's available in Windows. 1983, there was RFC for DNS. 1984, the first DNS software. Okay, server also bind here, and that is Unix based. And then after that, there's newer RFC for DNS. 1034 or 1035. You just Google it. Okay, so that's how it looks like before the DNS. Okay, about the DNS itself, it's very easy. So the concept is same. You translate a domain name here to an IP address. And after the browser knows the IP address, and then you'll access the web server using that IP address. Okay. So there must be a server here that is doing a service for DNS. Okay, so every host in the world, they will contact the DNS server so that they can translate the domain name into IP address. Okay, as simple as that. Look, guys, if you have questions, and then please say something in the group chat. Okay. Okay, so how DNS is managed? Okay, so this is important. Okay, especially if you are new to the internet, and then you want to manage your own domain. Okay, as I said. So, for example, you want to buy a domain. For example, Achmad.com. Okay, Achmad.com. Okay, you have in your mind that you want to buy Achmad.com. Okay, but even though DNS is managed by IANA here, but IANA itself did not acting as a body that receive requests from the customer. Okay, yeah. So IANA delegates its authority to Internet Registry here. Okay, so IANA, there is a body for Indonesia, and then from Indonesia we have a register to a local register. So they are like the one that is doing a reseller for domain name. So if you want to buy a domain name, you go to them. Okay, just go one of them and then check their price. Okay, so it's up to them. Yeah, okay, so you go to their website and then check whether how much is the price for a particular domain, and then that domain usually is $10 usually. .com. When I buy .com, usually it's $10. Okay, the price. I don't know how much is it now per year. And then we usually do it per year. Okay, so $10 per year. I don't know. It depends. Okay, if it is, yeah, it's like a business. Yeah, because .com is very crowded, so that's why IANA creates a new domains like .tv, .whatever. Yeah, yeah, because .tips, .whatever. Yeah, so that is to give you an opportunity to have a domain name. Okay, popular domain names. Well, most likely has been sold out, especially with the short one. Yeah, because yeah, lots of requests. Okay, yeah. So after you buy, and then after you go here, and then you go to their control panel. Okay. So IANA, oops. So this is IANA, and then IANA delegates to register. Register has their own panels, and then we can say here for managing our DNS. We just buy DNS, and then the DNS is not buy, but we rent per year. Okay, why do we need to rent? Because IANA needs to provide servers. Okay, and then the server is not free. Okay, they need electricity, they need whatever, yeah, maintenance, and so on and so forth. They have to pay a salary for their employee, right? So that's why the domain name is not free. Okay, because we need to operate the DNS system. Okay, and then yeah, it's provided by IANA. Okay, the DNS system in the world. Okay. So this is how it looks like. Okay, so from IANA to registrar, and then the register you buy, you just pick one of them, one of the register here. Maybe you're looking for the cheapest one. It's up to you. Okay, and then you define here your DNS server, your private DNS server. And then from here, you define the name of the server and then the IP address. Okay, so that your domain, okay, so everyone in the world, if they're asking your domain, they will ask here the IP address. Okay, yeah, like this one. Okay, so that's how DNS is managed. Oh, I have a question. There are many DNS applications available as Bean, Bind, DNS Mask, Unbound. Which one is easy? Well, for me, Bind is the oldest DNS, and then it's been used by many DNS server. Newest DNS servers like Power DNS is also good. They also have a user interface for that. But I will use Bind. Usually I use Bind, and then for the interface, yeah, well, you can use Webmin. Is easier. Okay, so this is DNS system. Okay, so this is the root DNS. Okay, this is a physical server. Okay, so this is physical server, and then this is the TLD server, like .com. TLD means top level domain. Okay, .com, .id, okay, .us, .eu, whatever. Okay, and then from .com they delegate to glcnetworks.com. Okay, and then from this glcnetworks.com into my NS. So this is my own domain server. So yeah, every person that buys a domain, they must have a domain DNS server. They must have a domain DNS server. But I never configured my own DNS server, meaning it's been configured by somebody, somebody else in somewhere else. Okay, yeah. So yeah, that's how it looks like. So we have an authoritative name server. So if the name server is hosting your domain, okay, so it means that it's authoritative server. Okay, if the domain name is just for resolving name, it's just a name server. So that's the difference. So this is address resolution mechanism. So you have a DNS server over here, a DNS client over here. So you are asking www.wikipedia.com. So first, the DNS iterator asks the root name server. Okay, so for example, this one. Okay, so try this one here. Okay, so one of the root server is asked by DNS iterator. And then second here, because this is org, okay, org. So you ask the org name server. You tell them, okay, I need to go to Wikipedia. Okay, boss. So this is the name server that is managing the wikipedia.com. Okay, thank you. So I will do another query for wikipedia.org. Okay, and then this is the final IP address. So this is the how it looks like for when we resolve an IP address. So we have a DNS iterator over here. Okay, so and then this is the client, CLT. The client sent to DNS iterator, for example, perhaps 8888, right? Google DNS, okay, and then the Google DNS will ask those name servers, and then after they get the name server over here, and then that name server become the caching server here. So they are caching the request for an amount of time, for example, 1 minute, 2 minutes, so that if there is a new request coming, I don't have to do the recursive looking again, the recursive query. Okay. Also, we have reverse DNS. Okay, so for DNS is to translate the domain name into IP address, but DNS, reverse DNS is the opposite, is from IP to domain. And this is very, very important for email. Okay, email. So if you have an email server, and then you want to make sure that that email server is not blocked by other email server because of it's not legitimation. Make sure that it's not used for spam. You need to set up a reverse DNS for your IP. Remember, reverse DNS is for IP, to convert an IP address to a domain name, the host name. Okay, so that was it. And about the protocol itself, well, the protocol for DNS, well, a long time ago, we usually use DNS port 53, UDP. Okay, so this is very common protocol for query. If you do query and then it's port 53, but this one has a drawback as well, because if you use yeah, I mean others routers can do that. They can do like a port forwarding. So all traffic that goes to port 53, the destination port is port 53, needs to be redirected to a particular DNS server. Yeah, yeah, it's UDP port 53 is susceptible for that one. Okay, and also we have a DNS over TCP here. This is for zone transfer. If you have a primary DNS server, and then you have we can call it slave. Yeah, sometimes the terminology in IT is a kind of racist, like a master and slave. black and white, like a black list and white list, like master and slave. Okay, but we use it already used it a long time ago. I mean, in years. I don't know. It seems like it's very hard to be changed. Okay, so yeah, DNS over TCP, so same port. So port 53 TCP, that is for zone transfer. And then we have a DNS script and DNS over TLS and DNS over HTTPS. So this is the features in router OS, DNS over HTTPS, but that depends on your location, your query. DNS over HTTPS sometimes very slow. Okay, so yeah, be careful for that. Okay, anything else? No. Okay, so let's next. Okay, live practice. What can we do for this? Yeah, perhaps I can show you an example of how we configure a DNS server. So I have my router here, not router, my server over here. Okay, so I will install a DNS. So aptitude update -y to make sure it is using latest latest repository index. Okay. Okay, this one is having issue. Bullseye release. Okay, perhaps we can just delete them. Vim etc, it is apt source list. Okay, this one, right? Bullseye updates. Really? Okay, let me check. Yeah, security Debian doesn't have release file. Okay, so it means that perhaps that one needs to be updated. Okay, I just put the comment there. Okay, save, do the update again. Okay, so I have another question. Is it okay if we create our own DNS recursive server? Yes, it's possible, yeah. If we create recursor server, what is the best source of the record? It is just from authoritative or the same recursor like 8888. So, so it means that you are setting up a recursive DNS. Yes, you can do recursive DNS using bind. So I'm using bind over here. Oops. So aptitude search bind, for example. Okay, so we have bind server. Okay, so this is it. So aptitude install bind. Oh, bind 9. Okay. Yeah, continue. And then, yes, as simple as that. And then my DNS server is running. Oh, I cannot do it like that. So system CTO status bind 9. Yeah. Okay, so this is Debian 11. So they have changed the init.d to systemd. Okay. Yeah, it's done. And then we can see net start minus tupln. Okay, let's check. Oh, okay, so we have a name D here over here. Okay, looks okay. Hmm. Mm-hmm. Yeah, it works. So I can do, yeah, if you want to do dig, yeah, if you want to check an IP address of a given domain name, you can use dig, for example, google.com, for example. Yeah, so here it is. This is how you read the results. Okay, so you do dig over there. Oops. Yeah. So you do dig. Okay, blah, blah, blah. And then here's the query. And then here's the status. Okay, no error. Okay, you have one query and then one answer. And then it's no authority over there. Okay, so it means that the DNS server that you are asking is not the one that is holding the google.com. Okay, so this is your question. Okay, this is your question. You're asking for a record. And then here's the answer, google.com in a, and then here's the IP address. Can you use other DNS server? Yes, you can just type here at, for example, 9999. Okay, so this is the answer. Same, right? So this is your question. Okay, and then your query answer is 6. Is it possible that google.com has 6 IP addresses? Yes, why not? So it means that we can say if somebody go to google.com, and then the first query will go to this server, second query for this one, third, fourth, fifth, and sixth. Okay, so, and then here's the server. Here's the query time. Okay, so you can check particular record for DNS. So this is, if you don't specify, it means that they are asking automatically for, they will assume that you are asking for a record A. But we can check the record like NS. Okay, it's like this one here. Okay, authority is still 0. Okay, NS 1, 2, 3, and 4. You can check MX, right? MX for mail exchange. Okay, so that's the Google emails server. Okay, again, this is NS. You can check also. Well, you can change it like this. Change it to looking for a to one of the DNS, Google DNS. Okay, for this one. Yeah, so here it is. Okay, authority is 0. Okay, so that's how it looks like. Okay, how you configure that's how you do a DNS query. And what about to set up a DNS server? Yes, it's possible. You can create a files directly, ls-l etc bind. Okay, and then here it is. Okay, so these are the name, the files that you will be using for your own domain. Also, other files are located in var lib bind. Yeah, bind. Yeah, so these are for the for files for detail for your domain. Usage of bind is normally is done by text file, okay, and then they have a format for text file, and then you can modify them and then restart the bind. Okay, as simple as that. But sometimes, often, not sometimes, often, for newer person who new to bind feels that this is very difficult. Okay, so that's why some software they created an interface for configuring bind, and one of them is Webmin. Okay, so I will install Webmin. But you are install Webmin. This is not true, administrator. What the hell, man? The purpose is you set up a service is up and running. Okay, so Webmin gives you a benefit for configuring that. Okay, but again, Webmin is just an interface, but not all of the bind features is covered by Webmin. Okay, some of them are not or difficult to find, but you need to know the format of the bind a text file. Okay, bind configuration files. So here I'm installing Webmin, and then it takes time. Oh, wow, up to 12 minutes. Oh, it's quite long, man. Well, perhaps I can check other server. This is our internal server 10.40. I mean, just for testing. Okay, similar to like what we see here. 7.5.53. Yeah, perhaps this one. Okay, so here it is, the Webmin. This is what happened if you install Webmin. Okay, so this is what happened if you install Webmin. After you finish install Webmin, so this is how it looks like. Okay, you just go to menu on the left and then click bind, and then you create here a master zone. Okay, for example.com, yeah, and then master server is ns dot, for example, glc networks.com, for example. Your email address, Achmad at glcnetworks.com. Okay, and then create and done. Okay, so here you can create an NS and then you create a record. Okay, so for example, host one dot some host one, yeah. Host one address is 1111. Okay, you create. It's done. Okay, return to record types. So actually you can write directly to the record files here. Yeah, so this is how it looks like. The bind configuration files. So either you can edit the files directly, or you can use other software to help you configuring bind. Okay, so this is what it means. Okay, so this is your domain name, INSOA start of authorization, and then here's your NS, and then here's your email. Okay, so this is how the email is written. And then here we have a serial number over here. And then I forgot, I need to check the documentation about these numbers. Yeah. And then here's your record. Okay. So the first record here is the NS. So example.com, its NS goes to ns.glcnetworks.com. And then here's host one is 1111. Okay, so as simple as that. You can use VI to copy and paste the lines, or you can use other text editor. Okay, after that, you can just apply configuration so that it will update it the bind. Okay, so and then yeah, it still takes time here downloading Webmin. Yeah, but anyway, we already installed the Webmin already, so we can try it. Okay. We can try dig tns example.com. Okay. At 10.40.5.53, for example. Yeah, here it is. Okay, I got question and answer. And then if I ask type A, and then I want to know host1.example.com. What is the IP address? Okay, here it is, 1111. So it is similar to what I got from here. Okay, so here you can see. And then you can add here manually. Okay. Host 2. There's going to be 2222. Right. Save and close. Don't forget to restart. So apply zone. Okay. And then from here, you can ask host 2 example.com. What about host 3? Well, let's see then. So no. Yeah. So as you can see, here's the reply. Okay, here's the reply. So this is your questions. Okay, and then it's asking for this query, and then status is NX domain. No, NX domain means no domain. This is your query, and then you don't have any answer. And then here's the authority. Okay, so this is your section for questions, and then here's the authority. Okay, authority means the name server that is acting as a server that is managing the example.com. Okay, so this is example.com. Manage the DNS server is here, ns.glcnetworks.com, and then this is the email of its maintainer. Okay, just exactly the same as we entered in the bind. Okay, so I think that's all for today. Any questions so far? So hopefully that answered the questions. Who is it? Jonias, okay, Jonias Fortuna. Right, okay, yeah, welcome. Okay, so I have a question. How one domain have many addresses like facebook.com have many IP address? How about how it works? Yeah, it's called load balancer. Yeah, it's very simple as that. So this is you, similar to like Google, right? Like Dick, google.com. Yeah, as you can see, google.com has only one. Or facebook.com or metaverse.com now. Yeah, they have one. Perhaps we can say, you can see tick.com. Yeah, for example here. Yeah, for the tick.com, as you can see, the tick.com has 2 IP addresses. So it means that they have server 1 over here, SRV2 over here. Okay, and then this is the internet, connect to them, and then this is their database. This is, yeah. Okay, so this is you connect to the internet, asking, accessing one of them. So server 1 is over here, server 2 over here. So just load balancing. So there is a Google cache in our ISP. Is our ISP redirect to google.com or YouTube for this case? Oh no, usually they are doing it with the BGP. Yeah, so they usually do peering with the content provider so that they don't have to do, oh, okay, this one goes to there, that one goes to there. It will be routed automatically if you have a BGP. Okay, so if you have a direct peering with the Google, of course, the destination hop to Google will be shorter compared to other links. So it means that with that particular ISP, some applications like Google-based application like Gmail, YouTube, whatever, will be faster compared to others. Okay, so make sure that your ISP has a direct peering to Google, okay? Otherwise, sometimes it's slow. Right, anything else? Any other questions? No? Well, if no, then yeah, I have to inform last info here from admin, okay? So a request from admin to that okay, so this is end of the slides. Thank you very much for keep wake up, keep waking up until this end of webinar. Thank you for attention. Feedback, please. So this is our feedback URL. So just go there. I have shared the URL to the group chat. Okay. We have a list of events in our Facebook, in our website. For your information, I think in this November or December, we're going to have a BGP workshop. So it's 3-day workshop. Okay, and then in this BGP workshop, we will learn about how to configure BGP. Okay, about the information itself, the BGP workshop is available in the website, but the schedules will be decided later. So you just contact admin, contact@glcnetworks.com for registration. Facebook is available. Slide will be available on Slideshare. We have Discord here for Bahasa Indonesia, where you can ask questions over there. Recording will be available on YouTube. All right. I think that's all for now. Again, thank you very much. Oh, I have a question here. How to build CDN using Nginx seems to be a nice topic for the next webinar. Okay, okay. Yeah, thanks for the topic suggestion. Okay, I will keep that in mind. Okay, thank you very much for your suggestion. Very, very good suggestion. So I will take a note of that. Okay, please wait a moment. Before we go, please have a chat and have a picture with us. So wait a moment. Webinar. Please turn on your camera, please. Okay, so I think that's all. Okay, let's prepare. Thumbs up. Okay. For Mac, it's Shift, Command, and Function, right? Forgot the name. Forgot the combination. Shift and Alt and 3. Is it working? Oh yes, yes, working. Okay. Okay. Let's do again. 1, 2, and 3. Yes. 1, 2, and 3. Yoo-hoo. Okay. Guys, thank you very much for coming. Yeah, see you in the next webinar then. Keep safe, and then see you in the next webinar. Goodbye, and then see you later.